Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is logarithm, we are going to take the second lesson under evaluation of logarithmic functions. So let's begin. After completing the very lesson today, my dear student, you should be able to solve the more problems involving evaluation of logarithm without using a table. This is what I hope you'll be able to do after completing the very lesson today. As usual, my dear student, in your favorite segment of the lesson, that is Maths is Fun. Today, I'll give you another amazing number, another interesting number, and that number is 66. 66 is another special number. I'll tell you what is special about this very number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let's just move quickly to more examples, starting with the very first one, where we asked to evaluate the following without using a table, meaning without using for figure table. The very first question, Roman where it says log to base 4 of 2 plus log to base 4 of 32. Question Roman 2, it says log to base 2 of 80 minus log to base 2 of 5. Solution to this very problem, starting with the very first question, copying the text there. That is log to base 4 of 2 plus log to base 4 of 32. What you now used here is the laws of logarithm plus the properties of the logarithm. This is what we are going to use to answer any question as far as this simplification and evaluation of logarithm is concerned. So here at flying the law, the very first law, this log to base 4 of 2 plus log to base 4 of 32, because it's the same base 4, base 4. I can now rewrite this log to base 4, then open bracket, inside the bracket is 2 times 32. This number multiplied by this number 32. So you now multiply 2 by 32. Multiplication of 2 by 32 gives you 64. So you have log to base 4 of 64. What you now do next is to change 64 to index form, and you now use the 4 as the base of that indexed number. So 64 changed to index form gives you 4 raised to 3. So you now apply the property of that logarithm, which we learned in one of our previous lessons. This power 3 will now become a multiplicative factor here. So you now have 3 multiplied by log to base 4 of 4. We continue. So you also remember the second property of logarithm, which we learned in our previous lesson. If you have the base and the number is the same, log to base 4 of 4, this is nothing but 1. So you have 3 multiplied by 1. And 3 times 1 gives you 3. Let me just move to take the second one. The second one, we asked to find the value of log to base 2 of 80 minus log to base 2 of 5. We are applying the law of logarithm. Also remember, if you have log n minus log m, that one is the something as log n divided by m. So there I can now have log to base 2, then open bracket 80 divided by 5. The first number there that I wanted to find, it is log divided by the second number, but this must have the same base if the base is the same. So dividing 80 by 5 gives you 16. Let me write it, log to base 2 of 16. So what you now do next is to change 16 in index form and try to use the 2 as the base. Of course, 16 can be changed as 4 raised to 2 or 2 raised to 4. But I'll select 2 raised to 4 because of this base is already 2. So I'm going to have log to base 2 instead of 16. I now have 2 raised to 4. Second property of logarithm, this 4 will now come and multiply this. So you now have 4 multiplied by log to base 2 of 2. And log to base 2 of 2, that gives you 1. So you have 4 multiplied by 1. And 4 times 1 gives you 4. So this is also the value of this very logarithm. Let me just move and take another example. Example number 2, we asked to simplify, have log to base 6 of this bracket, inside the bracket is 9 over 4, minus 2 times log to base 6 of the bracket, inside the bracket is 4 over 3, then plus the 2 multiplied by log to base 6 of open bracket, inside the bracket is 8 over 3. This is what we asked to simplify. We find the value rather. Solution to this very problem, copying the given task there. What we now do, we always apply the law and the properties of logarithms. This is what we shall be doing. So what I'm going to do first is to apply that very property, that is this 1 over 2, this multiplicative factor. It will now come and be a power of this very bracket. Let's just see it. So this is my half, is what now changes into a power here. And this 2 also the multiplicative factor of log to base 6 of 4 over 3. That 2 now becomes a power to this bracket 4 over 3. Then the last one, that is 2 log to base 6. This 2 also become a power of that 8 over 3. This is what I just did here. I applied the second property of logarithm. So what I'm going to do next is to find like this, is to find what is 9 over 4 raised to the power of 1 over 2, 4 over 3 raised to the power of 2, 8 over 3 raised to the power of 2. Let me do that. So I'm going to have 3 over 2. 9 over 4 raised to the power of 1 over 2 means simply square root of 9 over 4. The square root of 9 gives you 3, square root of 4 gives you 2. And this 4 over 3 raised to the power of 2 gives you 16 over 9. And 8 over 3 raised to the power of 2 gives you 64 over 9. So I'll continue. So what I'm going to do next is to apply the law. Let me do that. So I'm going to have log to base 6, open bracket, 3 over 2 minus 3 over 2 minus this log. If you now take log outside, it gives you 3 over 2 divided by 16 over 9. Look at it. 3 over 2 divided by 16 over 9. And this addition means multiplication. So you now have times 64 over 9. This is, I'm just applying the second and first law here of the logarithm. So I continue. So what remains is to simplify what is in the bracket. I have 3 over 2 divided by 16 over 9. This division can be changed to multiplication. So you now have log to base 6, open bracket, 3 over 2, which I copied. Instead of division, I change it to multiplication. But instead of dividing by 16 over 9, I'm now multiplying it by 9 over 16. That is the reciprocal. 9 shifted up and 16 goes down. Then times 64 over 9, which I copied. So what remains is to do this simplification inside this very bracket. So you have log to base 6 of 6 after simplifying in this very bracket. And log to base 6 of 6 gives you 1. So the final result of this, that is the final value of this, where you simplify it to the final, what it gives you is nothing but this number 1. Let's just take one more example. Example number 3, we asked to evaluate the logarithm to base 2 root 2 of root 8 minus log of 0.001 without using a table. Solution to this very problem. Copying the given task, what we now do to answer this very question. Now look at root 8. Root 8, I can simplify it further because I can now factor 4 times 2 instead of this 8, and 4 is perfect. So this sort can be simplified further. Similarly, 0.001 can be changed to fraction. Let me do that. So root 8 will now give you 2 root 2. That is, inside the bracket, you have 4 times the 2 instead 8, and the root 4 gives you this to 2 outside, then times root 2. Then 0.001 change it to fraction gives you 1 over 1000. So I continue. So what I'm going to do next, is to change this 1000 in index form. It will give you 10 raised to the power of 3. But when that 10 to the power of 3, that is at the denominator level, is shifted as numerator, it becomes negative power. So you have 10 raised to the power of minus 3. So what you now do next is to apply the properties of logarithm. You can see this, the base is 2 root 2 and the number is 2 root 2. So this will give you 1. Similarly, this minus 3, applying the property will now become a multiplicative factor and it will multiply this. Let me just do that. So I'm going to have 1 instead the log of 2 root 2 to base 2 root 2, and this minus 3 becomes a multiplicative factor. So you have minus times minus 3, which gives you this plus 3 log 10. And the base, I keep saying, if you didn't see it, it is base 10. So this is log to base 10 of 10, which gives you 1 in the end. So you now have 1 plus 3 times 1. This one is this log 10. I replace it with 1 because the base is 10. So 3 times 1 gives you 3. So you have 1 plus 3 and this gives you 4 finally. This will now be the value of this very logarithm. With this, my dear student, I have come to the end of this very lesson. I hope with the few examples given, you'll be able to evaluate the logarithmic functions. Thank you for your attention. And let me just move to the last segment, Marcy's fun, and explain what is special about the number 66. So what is special, what is interesting about this number 66? 66 is the largest number below 2000 that doesn't contain the letter E in its spelling. That is, in the spelling of 66 in English language, if you are to write 66, you want to see this letter E in the spelling of that number. So all other numbers from 67 up to 1999, if you write them in words, you now discover that they contain this letter E in the spelling of those numbers. So 66 is the largest that doesn't contain E. Of course, there are other numbers below 66 that doesn't contain the letter E. But from 66 up to this 2000, all those numbers in between, if you are to write them, there must be letter E in the spelling of those numbers if you write them in words. So 66 is a very special number. We see more of these interesting things in mathematics in our subsequent lessons.